today and tomorrow we're going to talk about solving exponential and log equations, and then we only have one section left, I think, which is 3.6, which is all about application. So we can do the half-life stuff and exponential growth and interest and all that fun jazz. And then that's it. So I think we should be having a test like towards the end of next week, and then we'll start chapter 9 before Thanksgiving break, and that will be our last chapter. So definitely having a test like next weekish sometimes. But today I used to try to do this all in one day, but there's just so many different types of problems that I just can't do it. So that's why I broke it up into 2 days, and I just kind of did more of the easier type problems today, and then tomorrow we'll do the crazy stuff that makes you want to poke your eyeballs out. So. Or that's super fun, however you want to look at it. I like to look at it as a super fun way. So here are my reminders to you about things you should know when you're solving equations. And remember that IFS means if and only if. Someone pointed out to me that they used to think I always spelled if wrong, but it really stands for if and only if in math terms. We've written most of these down already, so if you feel like you know them, you don't necessarily have to write them again. But these are kind of things you want to remember when you're solving these problems. If you have the same base and different exponents, then you can always just set the exponents equal each other. So if a to the x equals a to the y, then you know that x equals y. So on some of these problems, I could give you on the no calculator part of the test, because you could just have to set them equal to each other. And the same thing's true for logarithms. If you have log base a on both sides, one logarithm equal to one logarithm, then you can just set these equal to each other. And so that's super great. I think we'll do those more tomorrow. And then the other big thing to remember is that exponential functions and logarithms are inverses of each other. So if you have log or a and log of a, then they just cancel each other out, and you get x. Or log a of a, they cancel each other out. So if you see a logarithm in your problem, you can get rid of it by raising both sides to that base. If you see an exponential function, you can log both sides, and that will cancel out. And the same thing with e and ln. E and ln are inverses of each other, so they cancel each other out as well. And this bottom thing is a reminder when you solve any equation, but most of the time we think about if you add 3 to one side, you add 3 to the other side. If you divide one side by 7, you divide the other side by 7. But that applies to anything. If you ln one side of the equation, you have to ln the other side of the equation. If you e one side, you have to e the other side. That's my favorite one to do, because how often do you get to say, let's e it? Not very often. I'm the only one that finds joy in that. But so, we're just going to jump in here, and I think I have like 8-ish examples. But just to give you a big variety, and the homework isn't so bad today, and there's not even that much homework. 10 problems maybe, 9 problems. I'm trying to count my problems very quickly. So, let's jump in. That's supposed to be a focus right here. With my little hint there in parentheses over there. I should have hid that from you, but. On the test, if I give you a problem like this, you don't necessarily have to do it without a calculator if I give it to you on the calculator part. But the first couple problems on your homework today are set up like this, where you should be able to give me exact answers without needing your calculator, because you should be able to write these with the same base. The weird part is, the book likes to write them like this with an extra number in front. If you see a problem like this, step 1 is going to be, let's get rid of this 2. So to get rid of this 2, do you agree I could just divide by 2? And I could rewrite this as 8 to the x equals 4. And if you just have an exponential equal to a number, your first thought should be, could I rewrite those with the same base? Could I write 8 and 4 both as one number to a power? What number could I use? 2, because 8 is 2 to the what? 2 to the third, and then I'd still have that x there. You can put parentheses there if you want. And 4 is 2 to the second, and that goes to that property that we just wrote down. If these are the same base, you can just set these equal to each other and solve it. So you can say that 3x equals 2, and then you're just solving for x. So you're going to divide both sides by 3, and your answer would be that the 2/3 power is what's going to make those equal to each other. You with me on that? Yes, no, maybe. So what if I gave you this? It's fraction, so I would just skip it and ask me tomorrow. Or maybe not even do it. No, I meant like your homework. But you didn't do it for today, so that means you have to tomorrow. Hold me to the every other day. The whole night? A lot. Oh my goodness. It's kind of, I think the weird part about this is I wrote it weird. I wrote 3/4 and it automatically corrected it to that little slash mark, but then it wouldn't write this one, so I wrote 27 and then underlined it and then entered and wrote this, so it kind of looks not so pretty. But the idea is, I can't change 3/4 because those are done for. But what about 27 over 64? Could I write those as powers? 27 is 3 to the 64 is 4 to the third, I think, right? 4 times 4 is 16, and if we take times 4 again. So is that the same as saying 3 over 4 to the third power? If you recognize that you're supposed to write them as the same base, even though it's a fraction, it's not that bad of a problem. We don't even have to work anything out, because if we can write them both as a base of 3/4, can I just say that x equals 3? Yes? No? Maybe? I think you have 9 problems on your homework. 3 of them are like these. Oh my goodness. We just did 1/3 of your homework. Let's do some more. Like this one. Oh man, you're seeing too much. What about 2 to the x equals 10? Can you write 10 as a power of 2? No. Which means sometimes you have to just get a not so pretty answer and your calculator won't be needed. So maybe if you want to write this in your note, you cannot or can't write as same base. So you've got to think of something else to do. And maybe you have some memories of this from last year, but we want to be able to get that x out of the exponent. If we had log here or ln here, could we use that property that we had yesterday that we could pull that x out front and make it multiplication? So I want to make this a log problem. So I can just introduce a log or an ln to both sides. I like ln better. I don't know why. I think just because it's, I don't know, shorter than log. So to me, to do this problem, when I can't rewrite it as the same base, I'm going to ln both sides. And as long as I do it to both sides, I haven't changed anything. And why do I want to do that again? Because now, can I use that property where I bring that out front, and I write that as x times ln of 2 equals ln of 10? And I just want to solve for x. Once I take it out of the exponent, that's just multiplication. So how am I going to get x by itself? Divide by ln of 2. And I get that x equals the ln of 10 over the ln of 2. Let's have a little break here and talk about some math no-nos on your test. Ln of 10 divided by ln of 2 does not equal ln of 5. You also cannot just cross out those ln's. Lots of people do that all the time. So remember, ln of 10 is just stuck together, ln of 2 is stuck together. But what you can do is you can type that on your calculator and you can get a decimal answer. And you should be able to tell if that answer is reasonable. 10 is between what two powers of 3? Powers of 2, I mean. Yeah, it's between, 2 to the third is 8 and 2 to the fourth is 16. So you should get an answer of 3 point something here. So it kind of checks your work. Just like we talked about before, you either need to hit enter after ln of 10 or you need to put parentheses around that. I can tell you on your test, which means on your homework, I want you to give me both answers on problems like this. I call this the exact answer. Like in the directions, I say, give me the exact answer and round your answer to 3 decimal places. So I like to see that, and then I want to see that you can actually give me the correct answer with the decimal, and I got 3.322. And you can actually check that. If you plug that in for x, 2 to the 3.322 should be pretty close to 10. Yeah, pretty close because you rounded, so it's not going to be exactly 10. Vague memories of that from last year? Maybe. I think the worst part for me in this section is there's just so many types of problems, so I try to give you an example of lots of them, and then I'm sure still there'll be one that shows up on the homework that won't be exactly like one we did in our notes. Deborah. In the directions, I'll say, I think usually I say round to the nearest thousands or round to 3 decimal places. Usually I take a half point off if you round wrong. Which stinks, but I do. On this one you do? Let's check here. It's not Casio, that's what's good. Oh wait, look, I need this design. Oh, that's so. If you do, we do that on like on my calculator, I can do enter, and then I can hit divide, and it uses that same answer. So I would say do that because the reason it's off a little bit is because you cut off decimal. Does that make sense? Yeah. That's a good thing. Say she was doing ln of 10 and hitting enter, and or no, she just wrote down the answer, right? That's and so I will talk about this when we do lesson 3.6 because I call that round off error. If you type in ln of 10, you get like 2.30258. She just wrote down 2.3 and then divided that by ln of 2. But because she lost all those decimals, it changed her answer considerably that it was off from my answer. And so if you're going to do that, my advice is either save that in your calculator where you can just hit enter or write down at least 5 decimals because then that'll keep your answer more accurate. Okay? That's a good thing to point out there. On this one, this is where our properties come in handy. If we can write this as one logarithm or one ln, then we're going to have an easier time to simplify this. And so what can we do with subtraction? Write it back together as division as one ln. So is that the same as ln of x divided by 5 equals 0? And how do you undo ln? What's the inverse of ln? E. So can I e both sides? E it. That's my favorite thing. You might have to actually write down another piece of paper or another line. But when you e both sides, it takes all that to the exponent. So e and ln cancel out, and you get x over 5. And what's e to the 0? 1. And how would I solve that? Multiply by 5, and look how nice that answer is. X equals 5. And then you look at the original problem, because you probably figured out that x equals 5 to begin with. ln of what minus ln of 5 equals 0? Oh, probably ln of 5. I never even think about it, that I could get the answer by just looking, because I just want to eat it, so. Yes, no, maybe? Really important that you put it together. You cannot e both sides when it's subtraction here. It doesn't cancel out like that. You wouldn't get the same answer, so that's why you have to put it back together as one ln first. Yes, sir?
I thought it'd be like ln of x divided by ln of 5.
When you put it back together, it's only one ln every time.
Okay.
So when you break it apart, you do 2 of them. But when you put it back together, think about yesterday when we had stuff like this, we would break it apart as ln of x minus ln of 5. So when you're going backwards, you only write that ln one time, every time. Okay, that's a very common thing to happen. So you want to make sure you remember that you always put it back together and you only write ln or log one time. Okay? Other questions about that? Let's do some more. This one is kind of like the one, actually there's one on your homework today that was just like the one from yesterday about the lumens or the intensity of the light or whatever, where you had to plug in x and solve for I. You can solve these problems just like that, but you can also use the inverse. So I'm going to solve number 5 2 ways. You pick which way you like best, and then you're going to solve number 6. All right, so 2 ways you can do this. One way is we can do just like we did with the ln. To get rid of ln, we e both sides because that's the base on ln. This is log base 2. So to get rid of this, it's not as fun to say, but we could 2 both sides. That doesn't make sense. But you can make both sides like 2 to the log base 2 of x, and then you can do this side too, 2 to the 5th. So it's just like I did when I used e, but I'm doing it with 2. I don't know what to say there. You can't say 2 both sides. But it works every time because 2 log base 2, those are inverses. They cancel out, and you get x equals 2 to the 5th, or x equals 32. So whatever your base is, you can do that to both sides every time. You can also do how I did that story problem yesterday, is you can just use the definition of logarithm. So alternative method here. Using the definition, don't we say this is the base, this is the exponent, this is the answer? So could I just rewrite this as 2 to the 5th equals x, base, exponent, answer? And I get the same answer. I don't have any work to show with this one because I just used the definition. I don't care which way you do that problem, but you need to know how to solve those problems. I tend to do it this way, but a lot of people do it this way because they think of E and ln and remember what to do there. But either way, you get 32. Questions about that? Your choice. Do number 6 if you haven't already. Either get rid of the 4 by 4ing both sides, or rewrite it using the definition and see if you can come up with the answer. I might walk around and look at your papers for a second to see if you're doing anything. Right? If you do like this, your 4 log 4 cancels out, and you get 1 minus x equals 4, which is exactly what you get if you do 4 to the 1st equals this. Like either way, you end up with that same problem. But the difference between 5 and 6 is you actually have to solve for x here. So I can subtract 1, and I get negative x equals 3. Divide by negative, x equals negative 3. So if you see log, base something, then those are your 2 options to do that. Yes?
So like whenever you're rewriting like with logs, so you usually would just have written once and then the negative log. But on one of them it was like negative log of x minus y over log of 3. Do you have log twice because the bottom is an actual number instead of like a variable? Or why is that?
What number was that on the homework?
Number 36.
That one we were using change of base, which means we were taking something and we were changing it to base 10. As opposed to, okay, so this is change of base. That's supposed to be an F. As opposed to if I had something like this, log of x minus log of y, right? If I just said put that together, I'm taking two logs and I'm putting them together. So I would write that as log of x divided by y. I'm putting it back together as one log. This one, the direction said write in terms of common logarithm. So they're making you use the change of base formula. So that's the difference. Change of base formula, you change the original base to a new base, so you write log over log. But if you're just simplifying or condensing or breaking apart, you don't write it twice. Okay?
So when you change the base, I'll just write that like that.
Yes. Okay. Ooh, I was a little confused. Two more here. We haven't done any with E yet, but remember that E and LN go together. So when I see a problem with E in it, I know that I'm probably going to need to LN at some point. But don't LN right away. You need to get that E by itself or as much by itself as you can to begin with. So do the algebra. Just get E to the x by itself. So I'm going to add 14. And I get 3e to the x equals 25. And you could ln at this point, but I think the better choice is get e all by itself. So I'm going to divide by 3. And I get that e to the x, do not write that as a decimal, is 25/3. And then just like to get rid of ln, we e both sides. To get rid of e, we're going to ln both sides because they undo each other. So I would get ln of e to the x equals ln of 25/3. And what happens when I have ln of e to the x? Yeah, ln of e is just 1, or they cancel out. You could think about bringing the x in front, or you could just think about that just cancels, and you're left with x equals ln of 25/3, which will be the same as ln of 25 minus ln of 3, which is what you would get if you ln'd at that step before. This would be an example where I want both answers. This would be your exact answer, and then you can type that in your calculator. And this one you don't need to close the parentheses because it's not ln of 25 divided by ln of 3. It's ln of 25 over 3. All of that is in your ln. And you should get like 2.120. Yes? That's not so bad, right? What do you want to do? Go to sleep? You already are. ln of the square root of x plus 2 equals 1. There's actually a couple ways you can solve this. It's just whatever you see first. So what do you think? ln of something, and it's just the ln, which means we could e both sides to begin with because that's going to get the ln to go away. So we could say e to the ln of the square root of x plus 2 equals e to the first. So e and ln cancel out, and I get the square root of x plus 2 equals e. Then what could you do? What should you do? We gotta get rid of that square root, so we need to square both sides. And we would just get x plus 2 equals e squared. Get x by itself, so I would subtract 2. So I think the exact answer there would be e squared minus 2. And the approximate answer, I would type that in my calculator. And again, be careful on how your calculators are. My calculators automatically put a parenthesis by e, so you need to close that parenthesis, or you need to hit enter and then subtract 2. E squared minus 2 should be like 5.389-ish. Yes, no, maybe. What's wrong, maybe? Because you need to wait till the end. I want an exact answer, so don't use your calculator till the very end. Because your answer, like, you're gonna give me, you should still get to this at some point, but I want exact and this, which means you should not type in your calculator until the very end. Okay? So, I have a little exit slip for you today. Look at this. It's like a homework quiz before you do your homework. Yes, so right, because E raises to a power.
Oh, yeah.
Ln of, or when you do like the 2 to both sides, like that's raising it to a power. But yes, when you ln both sides, it's a power.
Okay, I kind of
So, based on your notes, you should be able to do this problem very simply. I want you to solve this, and I want both answers. I want the exact answer before you type in your calculator, and then I want you to type in your calculator and round to 3 decimals like we've been doing. So you should have 2 answers, and then when you're done, you can start on your homework. I'll double page this so that when you get done, you can see your homework. You're just doing 1 through 17 odd today. And yes, they're odd, but they should probably have some work to go with them, and then I'll just take it when you're done.
Yeah, right.
Yeah, we're here today.
Are we gonna have a working tomorrow?
Good.
That's a very vague answer.
I'm going to tell you, it's a piece of purpose homework quiz if I tell you when you're
Yeah,
going to have
it feels
it.
like every day that
But you should assume that you have one every day now.
it's not.
You should assume, but that's right.
Every problem that I just can't do.
Okay. And it's yes. It's like any homework quiz. Okay. Yes. Yes, as soon as I get all this.
Supersonic.
What day is it? This one week? I'll just have it.
Guess who's saying that?
You and Miss Scott, I'm like this.
Alright.
I think it's that long hearing. So is it
Yeah.
true?
Yes, she was.
Do you have it? Since 4. Did you ever work in 4 years ago?
Better in 8th grade.
That's cool. Yeah.
So like the exact.
Your son just turned 4. So. You're watching some old Pi Day videos. Passed out today. We had one from when Jermaine was a sophomore. So that meant the seniors were in 8th grade. It was so weird. So.
I was good. It'll be a while.
Yeah. It's my 8th year here. It's in
But it's for us. It's a lot of okay. Think about it this way. At ADHD kids were they used to get F's on your anti-ADHD. They would try to improve by giving you pens. Then when you would try using the pens, they would make JPGs. So imagine that being the best thing for us.
I got a C plus
need to call and Shane Shoemaker's the office, please.
Don't forget that assignment's different than the assignment sheet. You're just doing whether something not
Yeah, maybe I can get the right assignment this time.
on the right page.
Yeah. Maybe.
I have a test to come down the first hour. Will you take that test?
All right.
17 odds. We're not having a homework.
That's fine. Let's do the next one.
Okay, she might not give us one that's about our homework. They might. She'll probably. So that's the first one I've ever used my notes on a homework. Or like a quiz like that.
Oh, wait, will you hit that green button? Sometimes I totally forgot. Nobody's super